Good day, math thinkers! Are you ready to have this day filled with knowledge and fun? If so, come join us as we delve deeper onto the history of mathematics. We are your teachers for today. I am Benji B. Wadilla and my partner, Christian Rovic B. Campo. And welcome to the history of mathematics. Maging math talino at laging handang math tuto. For the past discussions, we are already through with the history of mathematics on the ancient Greek civilization, where we have learned about the various polymaths from Greece like Pythagoras, Diophantus, Eratosthenes, and the like. And for today's discussion, let us go back to the past again and investigate the history of mathematics of Islam, Hindu, and Chinese civilization. But before that, let us test your knowledge for our topic. Bring out your pens and papers and let us answer these together. Read the following statements carefully and write true if the statement is correct and false if the statement is incorrect. You are only given 5 seconds to answer the following statements. Let's see if your answers are correct as we go through our discussion. And without further ado, let's begin with Islamic mathematics. Islamic mathematics was established on the 8th century onwards during the Abbasid Empire. It was called the Golden Age of Islam because of their love for knowledge. Many scholars like mathematicians and scientists gathered in the country of knowledge which is located in Baghdad. But unfortunately, it was destroyed due to the conquest of Mongolians. Additionally, Muslims made a significant contributions in mathematics because they were able to merge and fuse together the mathematical developments of Greece and India. Moreover, Arabic served as the primary language of scholars, facilitating communications across different regions. What a vibrant history, isn't it? Let's now proceed with the different Islamic scholars and their contributions. First off is Muhammad ibn Musa al-Khwarizmi, a prominent Muslim mathematician and astronomer known for his major contributions on Hindu-Arabic numerals and concept of algebra. Did you know that algebra was derived from his name Al-Jabbar, which recognized him as the father of algebra? Al-Khwarizmi used the concept of algebra and land distribution, rules on the inheritance and distribution of salaries. He also authored the book, The Compedius Book of Calculation, by Completion and Balancing, which was his biggest book. He wrote 6 types of equation, namely, roots equals number or x equals 48, squares equals roots or x squared equal y, squares equals number or x equals 10, numbers and squares equals roots or 39 plus x squared is equal to x, numbers equals roots and squares or 39 is equal to x plus x squared, and squares equals numbers and roots or x squared equals 39 plus x. These equations are kind of familiar, right? Because we use this in algebra up to this modern math. The next scholar is Abu Kamil Shuja ibn Aslam. He was famous for being the Egyptian calculator. He was the first mathematician to use the irrational numbers as solutions and coefficients in equations. He also introduced algebra to European countries. Additionally, he was the first Muslim to work with powers higher than 2. Eighth power is the highest power he was able to work on. Lastly, he wrote several books which includes the Book of Algebra, the Book of Rare Things in Art of Calculations, and the like. Third is Abul Hasan Ahmad ibn Ibrahim Euclidisi, an Arab mathematician who focused on the positional use of Arabic numerals and decimal fraction. In his treatise in arithmetic, he introduced Hindu numerals and explained the place value system. He also collects arithmetical methods and converts them in Indian system. Lastly, he claims that up to his work, the Indian methods have been using with the blackboard in order to facilitate computations. Among his works are the Book of Chapters in Hindu Arithmetic and the Book of Records in Arithmetic, and lastly, Kushyar ibn Laba, a mathematician born in Iran. His famous work was the Universal or Comprehensive Astronomical Handbook, which was influenced by Ptolemy's Almagest, that contains many tables concerning with trigonometry, astronomical functions, and etc. What an amazing history indeed! But the fun doesn't end here. Let us now travel to the history of mathematics in Hindu civilization. During the early Vedic period, ancient Hindu civilization showcased mathematical concepts which includes the powers of 10, that demonstrates the concept of exponential growth. Mantras, on the other hand, are usually used in facilitating calculations and preservation of knowledge. Additionally, they have used mathematics operations that includes addition, subtraction, multiplication, division, fractions, and proportions. During the 8th century BCE, Sulba Sutras listed several Pythagorean triples like 3, 4, 5, and 5, 12, 13. And mantras, on the other hand, are usually used in facilitating calculations and preservation of knowledge. Additionally, they have used arithmetic operations that includes addition, subtraction, multiplication, division, fraction, and proportions. During the 8th century BCE, Sulba Sutras listed several Pythagorean triples like 3, 4, and 5, 12, and 13. Additionally, Jain mathematicians also recognized 5 forms of infinites that includes infinite in one and two directions, infinite in area, infinite everywhere, and infinite perpetually. Many considers Indian counting system to be one of the greatest intellectual innovations of all time because of the several reasons. One of these are, it introduced the place value concept where each digit's value depends on its position. Number 2, it introduced the decimal system, a base 10 decimal system which make calculations efficient and intuitive. 3, they use it in commerce and record keeping. And lastly, it represents large numbers efficiently, making it easier to utilize in mathematical and scientific calculations, unlike some other counting systems like the Mayans, which usually takes a lot of space when writing a number. And now, let's proceed with the Hindu scholars and their contributions to be presented by Mr. Christian Rovit B. Campo.
Aryabhata was a brilliant Indian astronomer and mathematician who lived in the 5th century CE. He is often considered the father of Indian astronomy and mathematics. His significant contribution include the introduction of the concept of zero, the development of sign, table, and the calculation of the value of pi to 4 decimal places. His work, Aryabhatiya, is a compendium of mathematics and astronomy that covers topics such as arithmetic, algebra, trigonometry, and planetary motion. We have a new one. Brahmagupta was a renowned Indian mathematician and astronomer who lived in the 7th century. He is known for his work on number theory, algebra, and geometry. His book Brahmasputa Siddhanta is a comprehensive treatise on mathematics and astronomy. In this work, he introduced the concept of negative numbers and zero and developed rules for arithmetic operations. Involving these numbers, he also provided solutions to quadratic equations and also discussed the properties of cyclic quadrilaterals. And next one is Bhaskara II was one of the greatest mathematicians of medieval India. He lived in the 12th century CE and is known for his work on calculus, trigonometry, and algebra. His most famous work is Lilavati, a book on arithmetic and algebra. In this book, he introduced the concept of the derivative and discussed the solution of nonlinear equation. He also wrote Bijaganita, a treatise on algebra, and Siddhanta Shiromani, a comprehensive astronomical work, and Varahamihira was a polymath and astronomer who lived in the 6th century CE. He applied mathematical principles to various fields, including astrology, astronomy, and mathematics. His most famous work is Panchadisa, which is a compendium of 5 astronomical treatises. In this work, he discussed the mathematical techniques used in astronomy, including trigonometry and spherical geometry. He also wrote Brihatsimhita, a comprehensive treatise on astrology which includes many mathematical calculations. Hindu-Arabic numerals are number system that revolutionized calculations and paved the way for modern mathematics. These elegant numerals born in India and transmitted to the Arab world eventually spread to Europe, transforming the way we think about numbers and computation. The Hindu-Arabic numeral system is based on 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This system is more efficient than previous number system, such as Roman numerals, and it is the foundation of modern mathematics. Chinese mathematics flourished for millennia, characterized by its practical applications. The Chinese invented the abacus, a revolutionary calculating tool that transformed commerce and science. The abacus is a simple device that consists of a frame with bits that slide on wires. It can be used to perform a wide variety of mathematical operations, and it also includes operations like addition, subtraction, multiplication, and division. Chinese mathematicians also made significant contribution to algebra, geometry, and trigonometry. They developed methods for solving equations, calculating areas and volumes, and studying the properties of numbers. Here's the scholar of the Chinese who invented many things. Liu was a brilliant Chinese mathematician and commentator who lived in the 3rd century CE. He provided detailed explanations and corrections to ancient mathematical texts. His most famous work is his commentary on the 9 chapters on the mathematical art, a classic Chinese mathematical text. In his commentary, he developed methods for calculating the volume of spheres, pyramids, and he also provided a more accurate value of pi. So Zhongxi was a polymath and astronomer who lived in the 5th century CE. Calculated the value of pi to an unprecedented level of accuracy, a feat that remained unmatched for centuries. He and his son, Su Kengxi, developed a method for calculating the volume of sphere. They also made significant contribution to calendar and engineering. Xin Ku next was a Chinese scientist and inventor who lived in the 11th century CE. He applied mathematical principles to various fields, including astronomy, meteorology, and engineering. His work on magnetic compasses and the measurement of time was groundbreaking. He also wrote extensively on the subject of mathematics, including works on algebra, geometry, and trigonometry. Next person is Li Ye, was a master of algebra who lived in the 13th century CE. He developed innovative methods for solving higher degree equations, laying the foundation for future algebraic advancements. His most famous work is Siyuan Hai Jing, which introduces new methods for solving polynomial equations. Next scholar is Qin Ji Xiao, was a renowned Chinese mathematician who lived 13th century CE. He made significant contribution to number theory, algebra, and the Chinese remainder theorem. His most famous work is Shushu Jusang, which contains many important mathematical results, including the solutions of indeterminate equations, and the calculation of astronomical phenomena. And the next important thing in the Chinese era is invention of the wheel. The invention of the wheel was a major technological breakthrough that revolutionized transportation and industry. The wheel is a simple machine that consists of a circular disc that rotates on an axle. It is used in a variety of applications, including vehicles, machines, and toys. The wheel is one of the most important inventions in human history. It made a significant growth in the industry. It has a profound impact on the development of the civilization. And
Most of us give little to no consideration as to how the numbers we use every day of our lives came to be. Did they spontaneously pop into existence? Have they always existed? Of course, the answer is much more complex and interesting. These numbers, often called Hindu-Arabic numerals, or simply Arabic numerals, as the name suggests, do not come from Europe, as many of you might have assumed. So, just how did the Europeans, and by extension most of the world, come to use today what we simply know as the numbers? Our story begins in the 3rd century BCE, in the Mauryan Empire, its current ruler Ashoka wanting to spread his edicts throughout his entire realm. As such, he raises a series of pillars throughout his domain containing these edicts. These edicts would be written in many different languages and different writing scripts. One of these would be called the Brahmi script, which had its own numerical system, the Brahmi numerals. As the pillars spread the emperor's edicts, these numerals would also spread with them throughout most of ancient India. In addition, as the centuries passed, these numerals would face significant changes. One of these changes would be the evolution from a system that relied on symbols with fixed values, including built-in powers of 10, to a positional numeral system, employing 10 as the base, that relied on 9 glyphs and a void, that could be used to represent a quantity that didn't exist, or to represent large numbers of different orders of magnitude. Another significant change happened later, in 628 CE, with the addition of the glyph 0 by the Indian astronomer-mathematician Brahmagupta, which would replace the said void. This would be the first time in history where 0 would be defined and treated as a number in its own right. The sum of two positives is positive, of two negatives negative, of a positive and a negative, the sum is their difference. If they are equal, it is 0. The sum of a negative and 0 is negative, that of a positive and 0 positive, and that of two zeros 0. By this time, however, the numerals were already spreading to the Muslim world, where they would reach a Persian mathematician by the name of Al-Khwarizmi, who, around 825 CE, would publish his book on the calculation with Hindu numerals. This work, describing the numerals, would eventually spread throughout the entire Muslim world. In the 10th century CE, these numerals would yet again suffer more changes, and they would split into two distinct variants: the Western Arabic numerals, commonly used in North Africa, and the Eastern Arabic numerals, commonly used in the Arabian Peninsula and Persia. From this point onwards, we shall focus on the Western Arabic numerals. During this era, North Africa was controlled by many Islamic dynasties, one of which would extend its domain to the northern shores of the Iberian Peninsula, the Umayyads. It would be there, in the Islamic Iberia, that these numerals, although without 0, would first be documented by Christendom in 976 CE, in a book by the name of Codex Vigilanus, a compilation of historical documents ranging from antiquity to the late 10th century Iberia. Around this time, a scholar by the name of Gerbert of Aurillac would travel to Spain and gain great fascination for all the knowledge the Muslims had, growing especially fond of mathematics and astronomy. Unsurprisingly, he ended up learning their numerals as well, which he avidly promoted when he was elected as Pope under the name Sylvester II by the end of the century. These numerals, however, would not gain as much popularity as one might expect. Anti-Muslim sentiment in Europe grew as the Crusades began in the following centuries, shielding Europe from many new Muslim ideas. A few centuries later, an author, now known to us as Fibonacci, would be born in the Italian Republic of Pisa. The son of a merchant, from an early age he travelled with his father across the Mediterranean, meeting with many a merchant and learning about their systems of arithmetic. He soon realised the advantages of the Arabic numerals over the Roman numerals Europeans had been using for millennia. As such, he compiled a book describing this system and its uses. publishing it in 1202 by the name Liber Abakshi. It would be in this book that the concept of zero would first enter Europe. With these 9 figures, and with the sign 0, which the Arabs call Zafir, any number whatsoever is written. However, these numerals didn't spread much outside of Italy, at least until the 15th century. Until this point, most of the documentation written in Arabic numerals was Pisan in origin, with Florence going so far as to ban the writing of 0 and all other Arabic numerals in the 13th century. This was due in part to the fact that Arabic numerals, unlike Roman numerals, are fairly simple to forge, with one able to vastly increase the value of trade by many magnitudes with a simple addition of a single digit, a practice that was almost impossible using Roman numerals. In addition, the concept of 0 made the business of granting loans simpler, a practice which was considered sinful to Christians as usury. However, this was about to change. With the start of the Renaissance, these numerals became more well known in the academic world, first throughout Italy and then to the rest of Europe. Later on, with the invention of the printing press, these numerals became standardized and spread throughout Europe's masses, having replaced Roman numerals by the 16th century. Special thanks to our Imperator level patron, Fernando Lopez Ojeda. As always, thanks for watching. Be sure to like and subscribe for more great historical content, and feel free to check our Discord and Patreon, linked in the description below.
That's for all, and the presentation is over. And again, I am Christian Rovic Campo and my partner Benji Boadilla. Thank you.